second solution of this problem is similar to the first solution. It is iterative that shifts right all elements at index I and above to make a room for the new value e. Then we add the element e into the index I. Except that we do the shifting starting from the index I and forward. Doing the shift starting from the index I and forward will add some complexity to the algorithm. Why? Because when we move the elements forward, all successor elements will be replaced and lost by the propagated element stored at index I. Therefore, we need to add some extra code to the algorithm to make sure that we save these values before they have been replaced and lost permanently. To show you what I mean by this, let us have this example. If we want to insert the element 10 at index 3, we need to shift all elements starting from index I and forward. So if we do forward shifting, first we will move 8 to the next element, replacing the value 1, and the value 1 will be lost forever. In the next iteration, the value 1 does not exist. It has been replaced by 8. So this 8 will be moved to the next element, replacing 9, and 9 is lost forever. In the next iteration, the same value a that has been propagated from index I will replace 6, and so on. So all successor elements after index I will be replaced by the propagated element at index 3, which is 8. From our previous discussion, to shift right all the elements starting from the index I and above to make a room for the new value e, we need to write extra code that is necessary to prevent the value stored at index I from propagating to the next elements. To do this task, we will write the algorithm in 2 steps. In each step, we will make the necessary changes until we write the algorithm completely. So what will be the first step? The first step is a simple for loop that will process the array starting from index I until index n-1. In every iteration, every element will be moved to its next neighbor element in the array. So how to write this initial step into pseudocode? In pseudocode, it is a simple for loop, so we write for, and the variable for the loop is k, starts from I to n-1. In every iteration, we move every element to its next neighbor element. To do this, we write a k plus 1 takes the value of ak. Now let us trace this code over our example. When we move every element to its next neighbor element, what will happen to the next neighbor element? The next neighbor element will be replaced by the previous value, will be destroyed and lost forever. So iteratively, if we continue this, then the value at index I will propagate through these elements, and all these elements will be replaced by this value and lost forever. So what changes we should make to this code to make it more accurate? Whenever we move the value at index k, so assume we are here, then when we move it to the next element or next neighbor, make sure that the next neighbor element is saved before it has been replaced by the previous value. So in every iteration, before we move any element to its next neighbor element, save this next neighbor element into a variable, so that in the next iteration, the value saved into this variable will be used for moving it to its next neighbor element. So how to do these changes to our initial code? We will decompose this statement into 2 separate statements. First, we will save the value at ak plus 1, which is the next value, will be saved to q. Then the value at k plus 1 will be replaced by the previous value, which is at k. And again, let us trace this code over our example and see how it works. Initially, the value of k is pointing to this element, and next element is here. In the first iteration, when we move the value at k plus 1 into q, this is the situation. So this is a q, and the value at k plus 1 is 1. Next statement, in the same iteration, we move the value at k to k plus 1. So we move 8 to its next neighbor, so the value 1 will be replaced by 8. In the first iteration, everything is fine. We are guaranteed that the next value, which was 1, was saved into the variable q. Now when we go to the next iteration, so when we move k to the next value, so k will be here and k plus 1 will be here. What will happen? When we move the value at k plus 1 into q, the value at k plus 1 is 9. When we move it into q, what will happen to the previous value of a q? The previous value in a q was 1. It will be replaced by 9. So what happened to the value 1? It has been replaced, destroyed, and lost forever. When we continue the iteration, we move the value at k. So the value at k is 8. We move it to its next neighbor element. So the value 9 will be replaced by 8. So now we have lost the value 1. When we move to the next iteration, so when we move k to the next iteration, so k will be pointing here and k plus 1 will be pointing here. Starting again from the beginning of the loop, we move the value at k plus 1 to q. So the value at k plus 1 is 6. See what happens? The value of 6 will replace the previous value, which was 9. So 9 will be replaced by 6, will be destroyed and lost forever. When we continue the iteration, the value at k, which is 8, will be saved into k plus 1. So 6 will be replaced by 8. So as you can see that all the values after the element stored at index I are lost because the value at index I has been propagated, replacing all of these values, and all of these values have been lost and destroyed forever. So where is the problem? The problem is that before we move a new value into the variable q, we need to save it to another variable. We will call this variable p. So let me show you how to do this. So we will erase everything. So now we have a q, this is a q, and this is p. Now initially in the first iteration, k was here and k plus 1 was here. So when we moved the value at k plus 1, when we moved 1 into q, and then we moved 8 in a place of 1, this was in the first iteration. Now in the next iteration, when we move k to the next iteration, so k will be here and k plus here, what will happen when we move the value at k plus 1 into q? Before we do that, before we move the value 9 into q, move the value q into p. So p will hold the previous value of a q, which will be equal to 1. And when we move the value at k plus 1, which is 9, into q, then the value 1 will be replaced by 9. So notice what happened. That the current value of a q is 9, and the previous value of a q was saved into p. So in the next iteration, when we go to the next iteration, we should not move the value at k to k plus 1 like what we are doing here. We need to move the value that is stored in p into k plus 1. So where to save the value of the previous value of a q into p, and where to save the value for the next iteration into k plus 1. We will go to our code and we will say that at the end of the iteration, we will save the value of a q into p. So before we go to the next iteration for a new iteration, before we save a new value at k plus 1 into q, we save the previous value into p. So when we enter this iteration, the value of a q will be the next value, k plus 1, and the value of p will be the previous value of a q. So we need to move the value that is saved at p into a k plus 1. And this will guarantee that for subsequent numbers will not be replaced by the previous values. Now the problem with this code is that what is the initial value of p when we start the for loop? Simply it will be equal the value of ai. So we will say that p initially is equal to the value at index I. So now let us trace the algorithm according to what changes we have done, and let us see if it works correctly or not. So we will erase everything. And when we start the algorithm, the value of k is here, and the value of k plus 1 is here. So now we are here. We will move the value of k plus 1 into q. So this is a q, and this is p. So we move the value at k plus 1. This is the value at k plus 1. It is 1. We will move it into q. And then the value of p, which initially is equal to 8, we forget to write this, will be moved into k plus 1. So the value of p will be moved into k plus 1, so 1 will be replaced by 8. And at the end of the iteration, we move the value of a q into p. So 8 will be replaced by 1, and that's it at the end of the iteration. Now when we move for the next iteration, so k will go to the next element, so k will come here and k plus 1 will come here. And we will start over from the beginning of the loop. So what is the value at k plus 1? It is 9. We will move it into q. So 9 will replace 1. And then the value of p will be moved to the location of k plus 1. So notice, we are not saving 8 into 9. We are saving p into the place of 9. So 9 will be replaced by 1. And at the end of the iteration, we move the value of a q to p. So 9 will be moved to p, so 1 will be replaced by 9. Now for the next iteration, when we move k to the next element, so now k will come here, and k plus 1 will come here. Again, we will start over for the next iteration. So what is at location k plus 1? It is 6. 6 will be moved to q. So 6 will replace 9. And the value in p will be moved to k plus 1. So p is 9. So what will happen is that k plus 1 will be replaced by 9. And at the end, the value in a q will be saved to p. So 9 will be replaced by 6. So now for every iteration, it is guaranteed that the next neighbor element is not replaced by the previous value and has been saved for the next iteration. So after we exit from the for loop here, we simply write that ai takes the new value, which is e. Now how to call the algorithm from a main program? First, we will give it a name. So we will say algorithm. The name will be insert. And the first parameter will be the array A. Next will be the index I, where we will insert the new value. And the last parameter will be the new value that we want to add or insert into the array. Now from the main program, and suppose here we are at the main program, we will write the name of the method. So here we are calling the algorithm. We will supply the array name. For our example, we want to insert the element e, which is equal to 10, at index I, which is equal to 3. So here we say that the second parameter is 3, and the third parameter is equal to 10. After we insert the new element into the array, remember that the size of the array will be increased by 1. So we need to increase the value of n by 1. So we say n takes the value of n plus 1. And this completes writing the pseudocode for the algorithm that inserts an element e at index I. So here is the complete algorithm that shifts right all the elements starting from the index I and above, and then adds the new value to index I.